Hey everybody! The purpose of this video is to get you some solutions to your homework that we turned in today from last time. It's about the one about rolling a die. So at some point you had to go get a die and roll it yourself. I'll take care of that here with a computer app. So anyway, number one just said imagine, don't actually do it, but imagine rolling a six-sided die. I asked approximate the fraction of the time the die will come up with 3 dots. So nothing special about that. I just picked one of the 6 numbers on a six-sided die. And I said, okay, suppose the number 1A, you rolled it 6 times. I wanted to know what fraction of the time should you see 3? If you had to guess, if you were rolling a die 6 times and had to guess, what fraction of the time you would get a 3. The way I would think about it is, I think about it, okay, a die has 6 sides. And it's pretty likely that if I rolled a die 6 times, we're going to do this in a second, by the way, I'm probably going to get some number repeated somewhere, like either 2 2s or 3 4s or a couple 6s or something like that. So it's possible that I would get 2 3s. So 2 3s out of 6. Rather than say 6 times, I'll put 6 rolls. It's possible I would get 2 3s out of 6 rolls. It's also possible I would get no 3s out of 6 rolls. It's also possible I would get 6 3s out of 6 rolls. All those things are possible. The question is, which is the most believable that would happen most often? So the way I would think about it is, I'd think about it, well, you're just as likely to get a 3 as you are to get a 4, as you are to get a 5, as you are to get a 6, or a 1 or a 2, really. So all of those should be equally likely to happen over the course of 6 rolls of a die. So if every one of the numbers is equally likely to happen over 6 rolls of a die, you would expect the same number of each of them over 6 rolls of it. I'm not saying that always happened, but I'm saying if you kept rolling a die 6 times and then 6 times, I would think you would get 1 roll of a 3 out of every 6 times you roll the dice. Now in statistics classes later on, you'll learn that we call that an average. On average, you get 1 3 out of every 6 rolls. You also on average get 1 6 out of 6 rolls, 1 1 out of 6 rolls, 1 2 out of 6 rolls, and so forth and so on. So then I just asked you for B and C is to put those out of 12 rolls and 24 rolls. So this was just, again, more of that multiplication of numerators and denominators by the same quantities to figure that out. So in order to get from 6 to 12, you'd have to double it. So to get from 1 to whatever, you'd have to double that. So you'd get 2 3s out of 6 rolls. And hopefully that makes sense. Every 6 times you roll, you're going to expect 1 3. So after 12 rolls, you'll expect 2 3s. And then to get to 24, you got some choices. You can start from 12 and go to 24, or you can start from 6. I'll just go from 12. So 12 to 24 is times 2. So 2 times 2 is going to be 4 3s. So hopefully this makes sense. Out of every 6 times you roll, you're going to expect a 3. Now that doesn't mean you're going to get 1 3 every time. It means you're going to expect to get 1 3, and you'll probably be the closest to what actually happens over a long period of rolling, which I was getting at you now, which is number 2. And basically, in number 2, I'm going to cheat a little bit here, and I'm going to use an online dice roller to do this for me. So I'm going to roll it 6 times here. I'm going to roll again. Okay, I just rolled it 6 times. I got a 2, a 5, a 3, a 2, a 4, and a 1. Therefore, I only got 1 3 out of 6 rolls. So I got exactly what I was supposed to have gotten. Now, before I go any further, I'm going to do this a few more times so you can see what happens. And I'm just going to call out from underneath. You'll hear my voice. Listen, I'm going to call out the number of times I get a 3 as I do this over and over again. So here we go. I just got 1 3 out of 6. I just got 2 3s out of 6. I just got 3 3s out of 6. I just got 2 threes out of 6. 3 threes out of 6. 1 3 out of 6. 1 3 out of 6. No threes out of 6. No threes out of 6. 2 threes out of 6. No threes out of 6. 1 3 out of 6. No threes out of 6. 1 3 out of 6. So hopefully you see what's going on here. In class today we did some averaging by sharing. So did you catch how there were a couple times I got 3 threes out of 6, and then there were also a couple times I got no threes out of 6? So if you borrow from the threes and give to the zeros, you begin to approximate what's known as the average, and we would average to 1 3 out of 6 rolls if I kept doing that over and over again. The next one I said 12, so I'm going to go back and change this to 12 dice. 12, here we go, roll my dice, now I'm going to count them. 1 2 3, I actually got 3, not 2, but for B, for me, I got 3 threes out of 12 rolls. So I was off a little bit, I got a little too many threes. Now I'm going to do this again. I'm going to do the thing I did last time where I just, okay, good. I'm going to roll again. That time I got 2, which is exactly what I was expecting. I'm going to roll again. That time I got 1, which is actually less than I was expecting. Now think about this. That time I got 3. The next time I got 1. The next time I got 2. Think about that. That's 6 total rolls. If I spread that evenly over 3 attempts, that's 2 each, which is what on average you should have gotten. Good. I think you get the point. C, I got to go back and change it to 24 dice now. Here we go, 24 dice. Here we go, 24. Roll the dice. I was expecting 4. Let me count. 1, 2, 3. I got 3. Not enough that time compared to what we were predicting. 3 threes out of 24 rolls. All right. So in this one I was spot on, and this one I was 1 low, and this one I was 1, excuse me, this one I was 1 high, that one I was 1 low. And then part 3, I said, how different were your fractions? And I said to subtract. So for mine, well, I was expecting 1/6. I got 1/6. That means there is no difference. I got exactly what I was expecting. There's no difference at all. For part B here, for part B, this is the bigger fraction because it's got 1 more up top. I do 3/12 minus 2/12, and this is where your old fraction skills come in handy. When you add and subtract, if you have 3 of something and then take 2 of something away, how many do you have left? So don't let the 12ths hang you up. That's just a name for something you have. So if you have 3 of these things here and you take away 2 of them, you're going to have 1 of those 12ths remaining. So you're off by 1/12. Same thing with this one. You expected 4 out of 24. You got 3 out of 24. If you subtract them, that's 1 out of 24. So that's what I got. Your numbers are probably going to be a little bit different than mine because you probably got different results than I got for number 2. And then last but not least, I said, okay, if you roll the die 96 times, which I hope I can do here, I'm going to do this on the computer, how many 3s would you expect? I didn't actually ask you to roll this, but I asked you to expect it. Okay, so we know that we expect 1 3 out of every 6 rolls. That's what we expect, and that's hopefully what you're seeing is happening. What we'd like to do is, using that fact, let's go to 96 rolls, right? Yeah, 96 rolls. How many 3s would I expect? So you had to do a little bit of math in your head here, or on paper, or whatever. You had to figure out, how do I get from 6 to 96? What do I multiply by? And hopefully you're able to figure this out. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. And eventually, if you get tired of doing this, and hopefully you'll figure out that 6 times 16 gives you 96. 6 times 16 gives you 96. Which means we multiply the top by 16 also, and we would expect 16 3s out of 96 rolls. And you bet it, we're going to check it right now to see. I'm going to roll this puppy dog 96 times. Let's see what it looks like. Oops. Will it let me do it 96 times? It will not. It'll let me do it. Okay, I can't do it 96 times. So I can do it The most it'll let me do is 60. So I'll do 60 and then 36 and we'll add them together. Okay, so 60. If I roll the dice, here we go. Okay, here I'm going to count them up. 1, 2, 3, 4, 5, 6. You know what? This is boring. You can't see this. Let's have you add it with me. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so that's 14. Now I'm going to go back and I'm going to roll 36 more times to finish off the 96. Oops. 36 more times to finish off the 96. 15, 16, 17, 18. We got 18 threes. We were expecting 16 threes. We got 18. What I find the most fascinating about that particular example right there is we got too many threes in the first 60. Did you catch that? Out of 60, if we think about it this way, out of 60, if we're expecting 1 3 out of every 6 rolls, we should have only gotten 10 threes in the first batch. Because 6 to 60 is 10, 1 to 10 is 10. Well, we got 14. In the next set, where there was 36, we should have gotten 6. 6 times 6 is 36. We only got 2. It's almost like the dice, we got 4, excuse me, we got 4, that's why we had 18. It's almost like the dice corrected. So they rolled too many and then not enough, and then it smoothed out to almost exactly what it should have been. And that is something, we're getting a little ahead of myself here with statistics and probability. You'll get into that in 105 and 243 and 244. But that is exactly what you're seeing, the kind of the miracle of the law of large numbers, as don't worry about that right now, you'll learn it later. Anyway, I hope that helped. We'll catch you in class.